This is Chloe Burdett. She pitches around 35 miles per hour, which is about 16 meters per second. This is Faith Rush. She pitches about 60 miles per hour, which is roughly 27 meters per second. If we want to find the acceleration for both pitches, we must first find the change in velocity and the time it takes for the pitch. The change in velocity for Chloe is 16 meters per second, and the change in velocity for Faith is 27 meters per second. We then divide both of those by 1 second because that's the time it takes for the pitch, and then that gives you your acceleration. The force of the bat has to be greater than the force of the softball in order for the softball to be sent out of the park. Newton's second law explains this with the equation force equals mass times acceleration. What does this mean? It means that the mass and the acceleration of the bat has to be far more than that of the softball.
Newton's first law says that objects will remain in their state of motion unless a force acts to change the motion. This is shown as Faith dives back towards the bag because her momentum is moving forward while the friction against the ground is slowing her down.
When the ball is hit, the force of the bat pushes the ball up while the air resistance and the gravity slows it down until it reaches a stop, or in this case, when Faith catches the ball.
If you use the same force to hit a baseball versus a softball, the baseball will go farther due to it being lighter than a softball.
A force is a push or pull that acts upon an object as a result of its interaction with another object. These two forces are called action and reaction forces and are the subject of Newton's third law of motion. Formally stated, Newton's third law states for every action there is an equal and opposite reaction. You can see Newton's third law being applied when the ball hits the bat. The bat is also hitting the ball in order for it to launch in the air.
Friction is a force that resists motion acting between two bodies in contact. This is shown as Faith dives forward. The friction of the ground resists the motion, causing the net force to equal 0, which causes Faith to stop.
Horizontal components are not affected by vertical components. In the absence of air resistance, when Faith hits the ball, it continues at a constant speed until gravity pulls it down and it hits the ground and rolls to a stop. A way to find the horizontal component of a ball is by using the formula x equals vx times t. In softball, there are two factors for exactly how long the ball stays in the air, and they are gravity and time. Gravity is always acting on the ball, so the formulas you would use to find the vertical components are y equals a times t, y equals 1/2 a times t squared, and y equals v initial times sine of theta times time plus 1/2 times gravity times time squared.
When you combine the horizontal and vertical components, you then get the angle of the softball as well as the parabolic path it will travel.